A 40-gram sample of glass is put into a calorimeter that contains 250 grams of water. The glass sample starts off at 85 degrees Celsius and the temperature of the water starts off at 20 degrees Celsius. When the temperature of the water stops changing, it's 22.3 degrees Celsius. The pressure remains constant at 1 atm. Calculate the specific heat capacity of glass. So when you put together glass and water, always remember that the Q of the hot substance is equal to the negative Q of the cold substance. So in this question, glass starts off at 85 degrees Celsius and water starts off at 20 degrees Celsius. So clearly, our hot substance is the glass and our cold substance is water. And if you can recall our equation for Q, Q is equal to mc delta T, right? Or mass times specific heat capacity times change in temperature. And we know the change in temperature is equal to the final temperature minus the initial temperature. So what you're going to do is we will expand both sides of the equation. So for the left side, that's mass of glass times C of glass times final temperature minus initial temperature equal to, for the right side, that's negative M mass of water times specific heat capacity of water times final temperature minus initial temperature. So now that we have set up the equation, let's now plug in the values. So according to the problem, the mass of glass is 40 grams. So we put 40.0 grams. For the specific heat capacity of glass, it's unknown because it's what's being asked in the problem. So just put Cg. According to the problem, the final temperature is 22.3 degrees Celsius. So you put there 22.3 degrees Celsius minus the initial temperature of glass is 85.0 degrees Celsius. And for the right side, we have negative. The mass of water, according to the problem, is 250 grams times the specific heat capacity of water. Although it's not given in the problem, you should have memorized its value. That's 4.184 joules per gram degree Celsius. Again, the final temperature is 22.3 degrees Celsius minus the initial temperature of water is 20.0 degrees Celsius. Okay, so since we are solving for Cg, what you're going to do is you will divide both sides of the equation by 40 grams times 22.3 degrees Celsius minus 85.0 degrees Celsius. So you do that on the left side, of course, you're also going to do that on the right side. Okay, so 40 grams cancels on the left side. The change in temperature also cancels on the left side. So what remains on the left side is the specific heat capacity of glass. And on the right side, grab your calculator and type the numbers. So that's negative 250 times 4.184 times the change of temperature of water divided by 40 grams times the change of temperature of glass. And if you do that, you will get approximately 0.959. And let's check how the units cancel out. The grams will cancel. The degrees Celsius will cancel. So the unit for specific heat capacity is joules per gram degree Celsius. This is the answer to the question.